We live in a world teeming with microorganisms. Understanding how those environments shape human health is so vitally important.
Built environments are all of the places where humans live, play, and work. When we talk about microbiomes, we're talking about the assembly of all of the microbes that are found within a particular environment. Now is the time to study the microbes in the environment and their interaction with the human body. PreMiEr was really created with the idea that we needed the tools to be able to assess the health of our built environments, as well as the tools to be able to operate those environments in a way that protects human health.
As we're facing challenges associated with increasing levels of inflammation disease, pandemic, antibiotic-resistant bugs, this particular center is going to take on those challenges head on.
One of the things that the PreMiEr Center does is it brings together basic scientists and engineers and allows them to work together. These problems cannot be solved by one great mind. They're going to be solved by dozens, if not hundreds of great minds.
Sensing and data are going to provide us with unprecedented opportunity to look at how the microbiome is interacting with humans in the built environment and engineer future microbiomes to pose less of a health risk to humans, and in fact go beyond just minimizing risk and improving health outcomes for the public. Another aspect of the center that is really going to be transformative are the test beds.
Test beds will range across different levels of environmental control and real-world conditions. They range all the way from a highly controlled lab environment to living laboratories of smart homes to hospital rooms.
This center has the potential to generate vast amounts of data because a lot of the technologies that we have, like sequencing technology, generate terabytes and terabytes of data. Part of what my lab will be doing is helping to organize and catalog and analyze these data so that we don't get lost in the data analysis stage.
At the core of all the work we're doing are the social, ethical implications of the research and its applications.
What does the public think about engineering the microbiome? What are some important privacy issues associated with either studying or engineering the microbiome? Who should own the microbiome? What are public perceptions of the technology, and how can we really ensure that they're deployed safely and equitably in society?
Diversity, equity, and inclusion is foundational to PreMiEr. In fact, when we were building the team, we intentionally picked people with those same values.
The whole personnel team role is really to build and sustain this culture, and within that culture, invite and bring people to the table and create this culture of not only inclusion, but a sense of belonging.
I know that the leadership of PreMiEr are very responsive to student voices, student needs. So I'm looking forward to improving the program as students give feedback.
We're going to be doing fundamental research to understand this microbiome in the built environment, to understand how it works. Along that path, we're going to discover new things that have commercial opportunity. I think students are going to be very, very excited, and I'm thrilled to work with them and help them turn their passion into something real and meaningful.
You know, as design professionals, we're each charged with an obligation to protect public health, safety, and welfare. And that's where I see the potential intersection with the research that will take place here. Doing something that might actually be regenerative or healing, or in the shaping of the built environment, do something that is really positive.
I think it's a really natural pairing with PreMiEr, how on their end you can really engineer that built environment and how we can take that information and think about how we want to engineer the microbiome within the human body.
So imagine a day when a doctor could walk into a hospital room and with a really quick diagnostic test be able to detect the presence of a pathogen before it infects an immunocompromised patient. The toolbox that we will be developing will be able to impact all microbiome engineering in agriculture, in climate change, and environment more broadly.
We're so grateful to the National Science Foundation. Their vision in understanding that these engineering centers can not only propel American science and technology, but enliven our community, enrich the pool of talent that is drawn into science and technology. It's precisely what we need to be doing at precisely the right moment.